I'm Jason Chen. As the announcer mentioned, I'm a developer advocate here at Google. And I'm here today to give an introduction to Android. And I'm glad to see that there are so many of you here. So let's get started. I think we had a great demo from Andy this morning. And what I hope to do is really give some background about what Android's about, tell you as developers what does Android mean, and also bring you up to date in terms of what the latest news is. So with that, we'll get started. So one of the things we always talk about, and I think you heard Andy mention this morning, was that just the sheer number of mobile users and how they compare. And Andy mentioned there's 1.1 billion PC-based internet users. And to compare, there's actually about 3.3 billion mobile phone users. And so I always like to show this graph up here to give you a graphical idea of just how big and how many mobile users there are, just to give you an idea of the importance and the size of the mobile market and the opportunity for you as developers in developing mobile applications. So beyond just giving some background in terms of the market, the other thing that I think Andy mentioned this morning it was about the Open Handset Alliance. The Open Handset Alliance is a group of 34 different companies, including Google, that have gotten together to collaboratively build Android. And eventually we'll release this as an open source project. And as Andy mentioned, there's really 5 different categories of partners in the alliance. The first are mobile operators. As you can see from the slide, there's also KDDI as well as Docomo, both operators here in Japan. And we also have other operators from around the world as part of the alliance. In addition to mobile operators, there are the handset manufacturers. These are the companies that build the hardware, the devices that get into consumers' hands. The next category of partners in the Open Handset Alliance are the software vendors. These are companies that build software and provide them for the Android platform. After that, there's also the semiconductor companies. So these are the companies that build the chips. They're part of the alliance because they are contributing to the effort to port hardware or port the platform to their specific chips. And then, of course, there are commercialization vendors. These are companies that help operators and manufacturers implement the Android platform for particular devices. So that's just a quick picture of who's in the alliance. And really what I want to get into next is the meat of my presentation. I want to talk about what is Android and what does it mean for you as a developer and what you'll be able to do with it. So the first thing I want to go through is a standard stack diagram. We'll talk through the various layers and give you a little bit of high-level detail in terms of what composes the Android stack. So the first part of the first part that's come in here is the Linux kernel. So Android is built on top, utilizes the Linux kernel for a couple of different things. The first is it provides us a well-known driver model. In addition, a memory management system, a security system, and also a well-known memory management system. So from the rest of the stack on up, the Linux kernel, it really looks like a hardware abstraction layer for the rest of the Android platform. So on top of the Linux kernel, we have the system libraries. And these libraries are written in native code, so in C and C++. They're compiled against libc, which you see in the lower right there. We have a custom implementation of libc. It's called, we call it Bionic, and it's written to be efficient and fast for a mobile device. In addition to libc, we have several native libraries to support some what we think are important and functionality. So you can see there's SQLite, there's WebKit, and also the media framework. SQLite is the database engine that's available to your applications. There's also WebKit, which is the engine that powers the browser on Android. It also powers the Safari browser on the Mac and PC, as well as the iPhone browser. And there's also the media framework. This is from our friends at Packet Video. They've contributed codecs for audio, video, and still images. And then on the far left, what you see there is the Surface Manager, our implementation of OpenGL-ES, and also SGL, which is our custom 2D primitives library. All the things on the left are related to graphics, both 2D and 3D. And I think the one interesting thing to point out here is that the Surface Manager can composite 2D and 3D at the same time on the screen at once, something I think doesn't happen on other mobile platforms. So beyond the system libraries, there's also the Android runtime. So this consists of the Dalvik virtual machine and the core libraries. The Dalvik virtual machine is a custom virtual machine that we've written. What we do is we convert the programs that you write in the Java programming language. We convert those class files into what's called .dex format. And that DEX format conversion is done at compile time. The Dalvik VM tech lead, Dan Bornstein, is here today, and he'll be presenting after me, so he'll give a lot of the detail about Dalvik and how it works and why it's different, and why we did our own VM. And then on top of the virtual machine runs the core libraries. So the core libraries are most of what you as a Java developer would expect to find in Java 2 Standard Edition. I say most because it's not all of the libraries, but it's most of them. And again, I have to stress that Android and with Dalvik is not a Java technology. We don't claim to be Java compatible. But what you do as developers is write your application using the Java programming language, and then take advantage of our core libraries and services. Speaking of everything else that you might do as a developer, the next layer in the stack is the application framework. And the application framework is really where you as a developer interact with the rest of the system. This provides a variety of different things. There's a bunch of managers and system services, and they provide access to your application to things like location. So if a device supports GPS or cell ID or some other form of determining the location of the device, that sort of information is managed and passed to you through that system service. And then there are other things like the window manager, telephony, the view system. These sorts of things are all essential system services that run and things that you can interact with from your program. And they also provide services to your application. And last but not least, and probably most important, are the applications themselves. So you can see up here, I've outlined home, contacts, phone, and browser. And then there's also a blank, empty fifth bubble. That bubble is meant to represent all the applications that you as developers will hopefully write for the platform. I called out the 4 that I did because they are included with the platform, but they are by no means mandatory. They're just something that we thought we would provide with the rest of Android. The point I want to make here is that both the home screen, contacts, the browser, all of these applications that come with the platform take advantage of the same exact APIs that are available to you as developers. And we did this partially because we wanted to prove to ourselves that the APIs that we were building were sufficient to create the applications that, sophisticated applications and interesting applications. But also we wanted the platform to be open. We didn't want to hide APIs or APIs from you as developers. So my point being, so all the APIs are available. So that's the system stack in a very quick nutshell. The next thing that I want to move on to is talking about the basics of an Android application. I won't be coding today because I only have about 45 minutes to talk. But what I will do is talk through the various concepts and outline some of the important things that I think, or that I want you all as developers to take away, and then hopefully go and write applications later on. So getting into this, there's really 4 main building blocks for Android applications. There are activities, intent receivers, services, and content providers. And there's descriptions up behind me of all 4. And really what I'm going to focus on today is talking about activities. Because activities, I think, are the most important thing that you as a developer will write. And also, it's the thing that your end users will interact with most. So my focus will be there for today. So activities and tasks. So before I get really into talking about the details, I want to define a couple of terms. When I talk about activities, what you should think about activities, the way you should think about activities is really, it's a discrete chunk of functionality. It's something that a user can do and interact with. Whether it's reading an email, sending an SMS, doing something in particular, think of that as being an activity. Now a task, which I'll also talk about later, is a collection of activities or a group of activities. And I'll get into more detail about tasks and how they relate to activities. There's also processes. In the Android framework for applications, your application is managed, so running processes and these sorts of things is invisible to the end user, but also something that you as a developer have very little control over. It's something that the system controls, and I'll get into more detail about what it does and explain why we've chosen to do this. And then the last thing that's up on the slide is the APK. So the APK is really how an Android application is packaged. It's simply think of it as a glorified zip file. It's just where all the DEX files and the images and whatever else you're bundling with your application is included in. And that's what's sent down to a device when an application is installed. So those are some of the terms that I'll be covering. And the next thing I want to show is an anatomy, a very, very high-level anatomy of an application. Whoops, I flipped forward too far. So so what I have up here are 2 abstract representations of what an Android application is. On the left is what I think is a fairly typical representation. That application has 2 activities, a content provider, an intent receiver, a service, and all of those things, all of those components of an application run in the same process. And this is something to point out. In addition, they're all part of the same APK file or package. The only real variation that you have on this sort of packaging scheme is what I'm showing up on the right. I left out the intent receiver simply because there isn't any room, but you can see there are 2 processes that run within that APK package. There's one that contains just the service, and then the other one has 2 activities and a content provider. The reason you might want to split out a service from the rest of your application is because you want it to be long-lived or it runs separately. And so that's one reason why you might have that. It's atypical, but it's not something that's totally out of the question. So I wanted to kind of show the exception up there. And so that's a bit about kind of the high-level overview in terms of structure. To talk about activities, there's a couple points to make. The first is really that activities are a concrete class in the API. So there is an activity class in the API that you will extend to create your own custom activities in your application. The next thing is also, at a conceptual level, an activity is really an encapsulation of some sort of operation. It's something that you want the user to be able to do. So if you're writing a photo gallery application, you might have a photo viewer activity as well as a photo picker activity, just to differentiate between the various things that a user might do in your application. Activities are also, they also run in the process of the APK that installed them. So I'll show how multiple activities can get started, but the point to remember is really that if you start an activity, either when the user starts an application or you start an activity from within your own application, the activities are always contained in the process that belongs to their package. And of course, earlier I mentioned that activities have a UI associated with them. That's actually optional. So if you want to write an activity where there isn't a UI, you can do that as well. And finally, the activities also have a context. So when you implement an activity, there's a concept or a class called context that you also associate with that particular activity. So I mentioned earlier tasks, and said that tasks were a collection of activities. Like you can see up here, that collection of activities can span multiple packages. So if you have an application that runs or that relies on other activities from other applications, you can spawn or span packages. The other thing to point out is that tasks, unlike activities, are more of a concept than an actual concrete class. They're a concept in the framework. It's something that you as developers should be aware of, but it is not something that it's not a class that you would implement. So just to point that out. Also, the reason there is a concept of tasks is that each task has its own UI history, because every time you start an activity, you put up a new image or you put up a new new UI on the screen. So if a user is moving between activities, you'll build up a stack of UIs, and within each task, you have a unique history. So if a user is moving backwards in those screens, it's only within the particular task. And really I know this is a bit abstract, but I think the way to think about tasks is to consider them as what users might think about applications on other platforms. So the traditional sort of application idea on like your desktop PC, that's what a task is roughly analogous to. So we've talked about activities. We've talked a little bit about tasks. The other thing that I want to highlight is processes. So within the Android framework, there's a couple things. An Android process maps one-to-one to a Linux process. And by default, there's only one process per APK. But like I mentioned earlier, if you want to run your service in a separate process, that's something that you can do, and is represented conceptually up on the screen on the right. Also, by default, since we're talking about processes, I should mention threads. By default, your process only has one thread. However, as Andy mentioned in the keynote, Android is a fully multitasking operating system, so if you want to spawn multiple threads from within your application, that's something that you can do. But by default, there's only one thread. You have to spawn your own threads and manage them within your own application. The other thing to point out is that there's all of the event queuing and dispatching for your various components, so your activities, your content providers, your intent receivers, and your services all happens through the main thread. So if you're doing work, if you're, I don't know, computing the 100th digit in pi, you probably don't want to do that in your main thread. Instead, what you want to do is spawn a secondary thread, do the computation or the work in that, and then update the main or UI thread with the result. That way you don't block on the UI, and the application for the end user stays interactive. Actually, a couple other points. Processes are controlled and started by the Android framework. The end user doesn't have to think about starting processes or quitting processes. They also don't have to, you as an application developer also don't have any control over that. But what you do, and so what happens is really that the system will take care of spawning a new process when you do things like bind to a new service or interact with a content provider or start a new activity that's not in your own package. And oftentimes these processes will remain running even though an activity or whatever sort of component was running there has stopped. And the system will reclaim and kill processes as needed. So the developer toolchain. So I talked a little bit. So now we've talked a little bit through the various components, which you can do, and how you put those together. I want to give you an idea of the tools that are available to you as a developer to build these applications for Android. So the first and I think the most important thing is that we have an Android emulator. This is available as part of the Android SDK. It is a QEMU-based ARM emulator, and it runs the same exact system image as a device. So there's no surprises when you move from running your application and developing it in an emulator to deploying it to a device. And because it's the same system image, you use the same exact toolchain to work with devices as you do with emulators. So if you're debugging or building on an emulator and then you want something that it doesn't quite work on a device, it's the same debugging tools, the same troubleshooting tools, so nothing really changes between emulator and device. So beyond the emulator, the other important thing that I think we built is the Eclipse plugin. So because you as developers write Android applications using the Java programming language, we knew that we would have to build tools for the popular Java IDEs, and we picked Eclipse because many people on the Android team use Eclipse and liked it, and there was a sensible way for us to build a plugin. So really what the plugin is it provides a nice GUI on top of all the command line tools that we've also built for building and troubleshooting Android applications. So if you don't like Eclipse, if you like NetBeans, or if you like some other Java IDE, you can certainly use those. I also know that because we've provided those command line tools, that people are building open source plugins for the other major Java IDEs. So that's the Eclipse plugin. The other thing that I wanted to show was just a picture of debugging. This is an image of what it would look like to debug an Android application. As you can see, it's not any different from your usual debugging for a Java program. And it looks the same whether you're on a device or whether you're still developing in the emulator. So I wanted to assure you, if you've done any Java development, developing for Android will feel very, very similar and comfortable. So that's a bit about the toolchain. What I really want to get into next is talking about what open means, because it's called the Open Handset Alliance. It's not the Closed Handset Alliance. So I want to explain for you as developers, what does open really mean, and why is that important, and why does that differentiate Android? So you can think of openness with Android as having three axes. The first is the industry. And when I say the industry, I mean handset manufacturers, operators, commercialization partners, these sorts of things, these sorts of companies that are bringing devices and mobile services to the market. And for them, Android is open for a couple of reasons. The first, and I think the biggest, is that the Android software stack will be open sourced under the Apache 2 license. And that includes everything that we can license as Apache 2. Our enhancements and changes to the kernel obviously are GPL, but everything that we can provide will be under Apache. The other point to make is that the source will be available after the first handsets ship. So the team is very busy, the Android teams are very busy working and perfecting the 1.0 product. And once we've done that and shipped, we will make all of the source available for free. And with that source, what that means is that anyone, even if you're not part of the alliance, can take that image or that source code and build a system image and put it on hardware if you have compatible hardware, or alter that system image however you like. So that's one part of this triangle. The other axis is end users. These are people who use phones, and your end users as application developers. There's a couple of ways that Android is open for users. And the biggest one, I think, is that users have full control over their experience. So they get to control what gets installed, and they get to control the defaults. And when I say they get to control what gets installed, I mean that users don't have to ask for permission to install an application. Likewise, if a user installs an application to replace an existing one, let's say you download a different browser because you like the one you downloaded better, you can set that to be the default, and so you as the end user always have control over the defaults and what gets installed. So the last portion of this triangle is, of course, the most important, is developers. And that's all of you out there, I hope. And Android is open for you in several different ways. The first is, and I think the most important, is that you don't need permission to ship an application. So this means there's no application certification. You don't need to send us or anyone else your Android application to make sure that it gets checked out. Just like on the web, where you don't have to ask permission to put up a website, we think that for mobile, you as a developer should be able to create an innovative application and make it available to your users right away, and be able to put it out there without having to work through any sort of intermediary. Also, like I mentioned when I was talking about the stack diagram, there are no hidden or privileged framework APIs. So this means that all the APIs that are available to you as an application developer, even so that you could do things like replace the home screen, or even theoretically write your own dialer application. So that's kind of open at a conceptual level. The other way that Android is open for you as developers is at a technical level. And the way that I like to summarize that is with 3 words. It's open because you can integrate, extend, and replace existing components in the system. And I'll get into explaining each of those in the next couple of slides. So I mentioned the first one was you can integrate with existing components. So in the screenshot that's up behind me, I've searched for 1600 Amphitheater Parkway, which happens to be the Google headquarters in Mountain View, or the address of the Google headquarters in Mountain View. And the Google search is returned, and I've clicked on the link to go to Google Maps. And normally on a desktop browser, we just you go straight to Google Maps and you see the location. Well, on Android, at least in the default platform build, you can go there in the browser, or there's also the Maps application, which we could launch as well. And what you're seeing up behind me is a dialog screen that lets the user choose do I continue to use the browser, or do I launch the Maps application? And since we're in the browser, since we're on a mobile device, we think that for Maps, it'd be great to have a separate application. So if you pick the Maps component, the Maps application will launch, and you'll see the location that you're trying to go to. And really what that illustrates is that there's a browser application, and there's also a Maps application. And the browser, all it has to know is that it wants to view a location. And when it tells the system that, the system will find the Maps application and launch it for the user and show it the location. And so in that way, separate applications with separate components are integrating together and working together to provide a seamless experience for an end user. So that's the integrate concept. The next one is extend. And extend is fairly straightforward, I think. The screenshot that I put up behind me is from an application that was one of the winners of the Android Developer Challenge. I think it's called Call a Cab. It's an application to make it easy to call a taxi. And what they've done is they've taken the map view component that we include as part of the platform, and they've customized it. Much like you do with the Google Maps API online, they've taken it and they've extended it, map view, and to put their custom components and really make it their own application. So this is really straightforward for them to do as well as you, because there's APIs, and it's just one other way that the platform is open for you as a developer. So that's integrate and extend. The last concept is replace, and I think replace is also fairly straightforward. Replace is really about being able to replace any component that's on the system. So what you're seeing up here is the contacts application. And it's the regular contacts application. It's kind of straightforward. If I, as an end user, didn't like that, or if I, as a developer, didn't like it and I thought I could do better, I could replace that with something like this. Actually, I didn't write this, but this is another one of our Android Developer Challenge winners. It's an application called Phonebook 2.0. And what they've done is they've done what they think is a better take on an address book. And it looks like you can see things like the status of your friends and these sorts of things. And my point in showing this is really that I want to illustrate that you can replace things like the address book. Because if I were to install Phonebook 2.0, and then if I were in the browser and I wanted to add to my contacts a phone number that I was trying to save from the browser, if I had installed Phonebook 2.0, instead of it going to the contacts application, I could make sure seamlessly for the end user that saving new contacts would show up in the new application that I installed as opposed to the old one. So my point being that if you as a developer think you can do better or want to provide a better alternative, the platform is open enough and makes available the means to do so for you. So we've talked about just how open the platform is and how you can replace components and these sorts of things, but I think you might have another question, or the other question that always comes up is, wait, what about security? You've said that the platform is open, you can replace components, and APIs are available, but how do you keep bad things from happening and keep the user in control of the phone? So there's a couple of things that we do for this. The first is that every application, when it's installed, is given a unique user ID. And there are no exceptions except for 3. And those 3 are the init process, a process that we call Zygote, and then the main process for the runtime, or the runtime. And those 3 are the only 3 that run under root. Everything else runs under its own user ID. So by isolating every application in its own user ID, that gives us, from the Linux level, process level on up, a sandbox or a way to sandbox applications from one another. And this means also that every application only has access to its own data. So if your application writes out sensitive data or data that you don't want other applications to get access to, it'll stay private and stay that way. And the other point, but if you do want to provide access to your own data, the only way for other applications to get access to them is through defined and explicitly exposed APIs. So whether it's issuing intents or binding to another service or working through a content provider, the only way that another application can get access to your application's data is if you explicitly allow it. The other thing about, the other way that we keep the applications and the system secure is through permissions. So if your application wants to access certain things like making phone calls or sending SMSs or other certain activities that we think are sensitive for a user, what you have to do is request the permission to do that in the manifest file that's included with your application. And when you do so, what we do is we show the end user when they install your application or an application that this application is asking to make phone calls, get access to your address book, and also send SMS. And we leave it up to the user to determine whether or not they really want to install that application. We think this is useful because if you're, say, installing a game and the system tells you that the application wants to make phone calls for you, you might think that might be a little fishy and not install that application. So that's a bit about security. And we've talked through a bunch of the different concepts about the building blocks for an application. So I want to kind of sum it all up for you as developers. What does this all mean for you? A couple of different things. The first thing is that Android applications are written using the Java programming language. So if you have experience writing applications in Java, you can use that same experience and leverage that for writing Android applications. The second is that there is a rich set of APIs and system services at your disposal. So this means that you can write and take advantage of a wide variety of functionality that can make your application even better so that you can provide a great user experience within your application. And the last thing is really that the platform is open. So you're able to get access to all sorts of different things. You can integrate, extend, and replace components, all in the name of creating even better applications than we've ever dreamed of. So we're really looking to you as developers to create the killer app that's going to make Android a huge success. So that's what I think, what this all means for you as developers. What I want to do now is catch all of you up on some of the latest news about Android. So in November of 2007, we announced Android and the Open Handset Alliance. We released the first iteration of the SDK in the middle of November, excuse me. And then in early January, started accepting submissions for the Android Developer Challenge. And then in the middle of February, we released a updated version of the SDK, what we call M5, and that's what's still available currently. And then in the middle of April, we closed submissions for the Android Developer Challenge 1, and we got almost 1,800 submissions. We were blown away by the number that we got from over, I think, 100 different countries around the world. And I think we got many from Japan as well. And then in the middle of May, we announced the top 50 of those 1,800 applications, as judged by a panel of, I think, over 100 judges worldwide. And I think there is at least one top 50 winner from Japan. So beyond that, what I want to mention is the Android Developer Challenge. The goal of the challenge, part one, and then there's also part two, is to help you as developers turn your ideas into great code and great applications. What we're doing in Android Developer Challenge 1, and as well as in part 2, is giving away $5 million in each contest, or in each competition. Challenge 1 is closed and over for new submissions, but there is Challenge Part 2, which you can all get into, and that will begin sometime after the first devices go on sale. We haven't determined when that will be yet, but we know it'll be sometime either later this year or early next year. The other thing I want to point out for you, because I've only been able to talk briefly about Android, are a couple of Japanese-specific online resources. The first is the site for documentation about Android, some of which has been translated into Japanese, and the address is up there. The other one below, the second one, is the Google group that has been started for Android SDK development, so where I think a lot of like-minded Android developers are gathering and discussing various issues and getting their questions answered by peers in the community. And both are in Japanese, and hopefully you can take advantage of them.